Today we'll go over analyzing data in text form using R, and this is the process we'll be following. We'll start by reading the file, reading a text file, and then we'll build a corpus. So corpus is a collection of documents, and then we will clean the text so we can take out unwanted things so that the analysis can be streamlined. As you know, text is unstructured data. So we create a structure by doing term document matrix. So we will convert the text file into term document matrix. You'll see how this is done. And then we'll make some plots and try to do some analysis. Once we develop plots, we may find that we need to fine tune few things, make some adjustments. So we may go back and forth to cleaning text and then again recreate term document matrix. So let's go to R. So we'll start by reading the file. We'll provide these options, and then I'm going to set a working directory where I have stored my files, and I will read a text file and name it as text. So we are using this command called read lines, and name of the text file is rai 2009.txt that sits in this directory. Let's run these lines. After reading this text file, you see there is a warning message. So getting warning message is fine in R. As long as this is not error, we should be fine. So in the console area, I'm going to just view few things. So I'm going to view 1 to 8 lines. So line 1 says IEEE transactions on reliability. So this is a journal article that was published in this international journal in 2009, and this is obviously page number. This is the title of the paper that was published. This is the author name, and then you have the abstract. So basically this file, which is in text format, has been read. So length of this document is 467, and this 467 includes some lines, some actually blank lines, and some paragraphs, and so on. Next thing we do is we'll build corpus. So note that the command that we use has capital C for corpus, and we are storing this in corpus. So let's run these two lines. So once we create a corpus, which is collection of documents, we clean text. So what this line will do is it will convert all alphabets to lowercase. So let's run this. And if you want to inspect and see, we can do inspect. Let's do 1 to 5. So 1 to 5 means first 5 documents in the corpus. You can see this capital I is now small case or lowercase. Same thing for T and so on. You can see same thing has happened to all the documents. So entire document now has lowercase. What we'll do next is we'll remove these punctuations like full stop and comma. So let's do that. So this line will remove all the punctuations from the entire corpus. So let's run and then inspect 1 to 5 and see. So you can see we had this comma and full stop earlier, so they are now gone. So next we are going to remove numbers like these 58, 4, 649 and so on. Now if we check first 5 documents of the corpus again, you'll notice that the numbers are gone. So we had 58, 4, 2009, so they do not exist anymore. And this has happened throughout the corpus. When we are analyzing text, we'll also see that in text we have certain words that really don't add value when doing some kind of text mining. So for example, for and by, so such kind of words can be removed very easily in R. So let's do that. Now instead of calling it corpus, let's call this as clean set. So what this line will do is it will remove certain stop words in English. If you want to see what are those words that will be removed, let's copy this and run this in the console. So you can see this is the list of words that may not really add value to our analysis, and like me, my, myself, to, below, etc. So all these words will be gone. So one example is by that we have in the title. So let's run this and inspect the clean set 1 through 5. So you can see those words that were here like forecasting for, subsystem, and also influenced by calendar month seasonality, they are gone. You can also create your own stop words and remove them. So you can specify your remove words. In this case, if you look at abstract, so this paper is about warranty, and this word warranty is going to appear at many places. Probably we can remove this word, and let's also remove word like also. So once we run this line, this will eliminate those two words. So let's again inspect document number 8, and you'll notice that those two words are gone, warranty and also. But you'll also notice that many places we have these extra white spaces, and this is created when we remove words. So when the words are removed that we do not want, some extra white spaces are created because of that. So we need to get rid of this also. So let's run this line and inspect document 8 again. So you will notice that compared to the earlier one where we had a lot of white spaces, this one is more compact. We have eliminated white spaces. So now we are ready to create a term document matrix. So we'll call the term document matrix as TDM. We run these two lines and it has created a TDM, which is term document matrix. Let's use one more line. Okay, so now we have TDM in a matrix form. So matrix means you have rows and columns. If you want to look at what is the dimension of this matrix, we can say DIM TDM. So it has 759 rows and there are 467 documents. It's a huge matrix. 759 is basically 759 different terms that we have in the documents, and 467 is number of documents. So let's look at maybe last 59 terms like 700 to 759. Out of 467 documents, let's look at maybe 7 to 10. Document number 7, 8, 9, and 10. So 8 document is abstract. So let's run this. So you can see this is the list of terms, and for example this use appears in this document. Remember, this is 7, 8, 9, 10. So this is the 8th document, and the term using appears 2 times in abstract, variables appears 2 times, and so on. So it's a huge matrix, and you'll see that it's a very sparse matrix. It has a lot of zeros in it and very few numbers. So now let's create a bar plot. So first of all, we are going to run this line where we are getting the total or sums of each rows in this matrix. We'll store this information in term frequency. If we have a word like used, so how many times it appears in the document. Let's do that. There are so many words that will appear maybe only once because this matrix is so sparse, and there could be a lot of words that just appear once. Let's put a condition and look at only those terms that appear at least 10 times. So I'm going to do that in the next line. So using this line, we are creating a subset, and we'll only include those terms that appear 10 or more times. So let's run this line. And if you want to look at how it looks, so let's do term frequency in the console area. So these are the most common words. This also tells you what is the frequency of each word appearing in the entire data set. So for example, year appears 42 times, multiplicative appears 10 times, and so on. So now let's do a bar plot. So this is how our bar plot looks. So these are the words that are in ascending order. So this is actually accumulation, then actual, and so on. You have like V, W, Y towards the end. So now you may notice that there are some words like, for example, claim and claims. Like warranty claim or warranty claims, they give same idea, and there's no point in having both of them. We should find a way to combine them into one and then have a bar so that it is more meaningful. So the way we do this is we want to replace one of them by the other. And the strategy should be we should not replace claim by claims because claims already includes claims, CLAIM. So if we replace claim by claims, there will be problems. So what we should do is we should replace claims by claim. So let's do that. So now we need to go back to the clean text area, and let me create a space here. So we'll be replacing claims by claim. So we run this line here and run all subsequent lines one by one, and then create a bar plot. So if you look at this new bar plot, so now claim and claims are combined into one, and you see the frequency of that is now over 80. So we may have to do this for many other words, like it could be month and monthly or months. These three can be combined into one, and so on. This line can be repeated for any number of words. So once we finalize our term document matrix by going back and forth between cleaning or removing words, etc., we can move on to Wordcloud. We can create Wordcloud using Wordcloud library. So what this will do is it will find row sums in the term document matrix, similar to what we did earlier, and store everything in word frequency. So you can run this. If you want to look at what we have, we can type word frequency and hit enter. So because this is in descending order, so you see these words that appear only once at the bottom, and at the top you have most frequent words. So month, for example, has appeared 83 times, claim 82 times, and so on. Next, we will make use of set.seed to make this process reproducible. I'm using 1, 2, 3. You can use any number that you like. And then we make the word cloud. So we can run this. Let me make some room so that we can have word cloud in this area. So let's run this. So there's a typo here. This should be names. So till we have this red light, we should let this analysis complete. So now it's done. So this is the word cloud we get, and there are a lot of words as you can see. So the most frequent words are bigger in size, and those words that are less frequent are smaller in size. So now if you want to reduce clutter, we can make use of max.words. We can limit the number of maximum words to any number that we like. So let's add max.words equals 50 and rerun this analysis. So now the number of words is limited to 50, or if you want to make it 100, you get a word cloud with 100 words. We can also reduce clutter by specifying minimum frequency. If we want only those words to appear that have occurred in the entire documents at least 10 times, then we can specify minimum frequency to be 10. So let's use this and run this line again. So we get a new picture. We can also add some colors. So we can make use of rainbow function. So now if we run this, we get slightly more colorful picture. We can add more colors using brewer.pl. We get a different color pattern. We can also change the scale using scale command. So this is the size of bigger words or more frequent words, and 0.1 is the size of smallest. So let's see what we get. Now if we want to reduce the size of bigger words and rerun this, so this is how it looks. If we want to further reduce the bigger ones to, let's say, 4, and slightly increase the smaller ones. So this is how this word cloud looks like. So you see some overlap here, but when you go to zoom, you'll see a more clear picture. Next, we can also rotate some words. So for example, if we say 0.2, that means 20% of the words will be rotated 90 degrees. So let's use that. So ROT for rotation, PER for percentage. So let's say 0.2. 20% of the words are now rotated. If we increase this to say 50%, there will be more words that are rotated 90 degrees. So this is what we see here. We have some more room, so let's add some more words by being less restrictive. So this is how the word cloud looks like for the data we have. It can be refined by using those commands that I showed you just now.